Sandy's Rocket Lab.
Starting the rocket!
Oh, SpongeBob.
With Cuba, Kim, Elliot, and David. Introducing
Professor Patrick.
Professor?
Dr. Professor Patrick. Don't mind him. You know how interns are.
Okay, Doc, let's talk procedure.
That's Mr. Dr. Professor Patrick to you.
Procedures.
This isn't for fun. See this? This is
Physics.
Set down the launching pad near a pole or wall. Check to see if the stand is perfectly straight. Attach the pump and the low valve to the launching pad. Make sure both are securely fastened. Place the rocket on over the valve. Be sure that everyone is a few steps back from the launching pad. Have someone hold a ruler behind the rocket to use as a point of reference when calculating the velocity of the launch. Alternatively, you can use something else, such as a brick wall, as your point of reference. Have one person use the bicycle pump until the rocket launches into the air. Use the video camera to record the rocket launch against its frame of reference. Stand clear of the rocket as it falls. Conduct multiple trials of the same valve to ensure accuracy. Repeat steps for medium and high valves. Using the footage of the launches, calculate the average total time for each valve, the time up, the initial velocity, the final velocity, and the maximum height of the rocket.
Does this look dangerous?
No, it looks fun.
F is for friends.
Remember,
who do
always
stuff
wear
together.
safety goggles.
U is for you and me. N is for anywhere and
Never
anytime
lean
at all.
over the rocket while it's being pumped, like so.
F is for fire that burns down the whole town.
Remember,
Use for
never
your
try to
radium
catch the rocket.
bombs. N is for no survivors.
Never stand under the rocket.
When you
Plankton. Those things aren't what fun is all about. Now, do it like this. I thought that I had everybody on my side, but I went and blew it all sky high. And now she won't even spare a passing glance. All just because I ripped my pants.
When Big Larry came round just to put him down, SpongeBob turned into a clown. And no girl ever wants to dance with a fool who went and ripped his pants. I know I shouldn't mope around, I shouldn't curse, but the pain feels so much worse. 'Cause winding up with no one is
Using the equation v equals d over t to measure the initial velocity. We know that the camera records at 30 frames per second. Thus, we plug in 1/30th of a second in for t. The distance is determined by the rocket's change in displacement in a single frame. Thus, we get an initial velocity of 13.5 meters per second. Using the equation Vf equals Vi plus At.
It's called the Ugly Barnacle. Once there was an ugly barnacle. He was so ugly that everyone died. The end.
That didn't help at all.
I'm Goofy Goober!
The velocity at the apex equals 0 meters per second. Plugging in the initial velocity previously determined, plus the acceleration, negative 9.8 meters per second squared, multiplied by the t. Solving for t, we determine that time equals 1.38 seconds or 2.76 seconds. Using the equation distance equals half at squared plus vit, we solve for the max height. We plug in the acceleration equals negative 9.8 meters per second squared times the time to get to the top, 1.38 seconds squared, plus the initial velocity, 13.5 meters per second, times time, 1.38 seconds. We solve and determine that distance equals 9.3 meters. Make sure all of your instruments work properly, so this doesn't happen.
Is mayonnaise an instrument? We call it pinning.
It's a giraffe! The rocket after a night of partying. There's the rocket. Look at that. Out cold.
I've got to tell someone about this.
Now to calculate percent uncertainty.
Hey all you people, won't you listen to me?
For time,
I just had a sandwich, no ordinary sandwich.
3.62%. For velocity, 0.37%. For distance, 0.54%. After determining the percent uncertainty for each variable, you add them up to get your total percent uncertainty, 4.53%.
After analyzing the results of all our calculations, we were able to come to some conclusions. It is important to keep in mind that we neglected the effects of air resistance during this experiment. The results of the experiment were as expected. The data showed us that the low valve had the lowest initial velocity of 13.5 meters per second and the lowest maximum height of 9.3 meters, while the high valve had the highest initial velocity of 16.5 meters per second and highest maximum height of 13.9 meters. This was due to the increased air pressure that was pumped into the rocket. The increased pressure creates a larger upward force. By using a digital camera, we were able to acquire data and calculations with much less experimental error. Even with the camera, however, there were still sources of error such as uncertainty in measurement and the inability to clearly see the position of the rocket on film. Although there is always room for improvement, we attempted to minimize errors and acquire relatively accurate data.
Xavier, you're getting in the eye with that. Let this be a message to the world. Yo, DOS that right now. Straight DOS.
Big one, take us behind those rocks.
Moving behind the rocks.
Keep going. You're good. You're good. You're good. And stop. Don't worry, Captain. We'll buff out those scratches.